Good afternoon. So in today's lecture series, now we'll be discussing about the M and N circles. Now the study of the closed loop frequency response, now it is very useful. Now as it enables us to use the second order correlations between the frequency response and the time response. So where now we can just see that the help of these correlations, the time domain specifications, they are first converted into a set of specifications in frequency domain. Now after design and compensation in the frequency domain, the frequency response is translated back into the approximate time response. So therefore the correlation between the frequency domain and time domain specifications are very essential for us in order to understand the response of a closed loop system. Now the various frequency domain specifications which are generally available now are the resonant peak, the resonant frequency, the bandwidth, the cutoff rate, the gain margin and phase margin. Now this resonant peak, now it is the peak value of the response, that is the magnitude of the closed loop frequency response, and it directly indicates or correlates the peak overshoot of your time response analysis. And second, the frequency response, that is the resonant frequency, now it is the frequency at which your resonant peak occurs, and this directly relates to the frequency of oscillation in a step response, and it is indicative of the speed of the transient response. And the next is the bandwidth, now which is or it indicates the noise filtering characteristics of your system. And similarly the gain margin and the phase margin, now they are the measure of the relative stability and they are relates to the closed loop poles of the j omega axis. So out of these specifications, the maximum value of M and the frequency at which it occurs, they are very important specifications of merit. Now from these specifications, now we have a graphical methods which help in determining this value of MR and the frequency omega r, and from these graphical representations now we can easily determine the closed loop frequency response. So that is, the response is identified from the open loop without directly identifying the closed loop response. So these graphical techniques, they are constant M contours and N contours, now which are generally called as the M and N circles. Now the M circles, now we consider a point g of j omega is equal to x plus jy. Now we just consider on a polar plot. Now the closed loop response of this is g of j omega is equal to x plus jy. Now where the magnitude is identified as M, so M is given, that is the magnitude of the closed loop response. Now squaring on both sides, now we just get this equation, and from which we cross multiply it, and finally we get this equation, that is cross multiplying and grouping the like terms together. Now finally what we do is, now we just divide the entire equation. This entire equation is divided by m squared minus 1. So wherein now we land up at this equation. Now adding m squared divided by m squared minus 1 the whole squared on both sides of this equation, now finally we obtain, that is x plus m squared divided by m squared minus 1 the whole square plus y squared is equal to m squared divided by m squared minus 1 the whole squared, which represents the equation of a circle. X squared plus y squared is equal to a squared. So which is the equation of a circle, now with center given by x naught is equal to minus m squared divided by m squared minus 1 and y naught is equal to 0. This is the center, and with radius which is given by r naught is equal to m divided by m squared minus 1. So therefore this M contours, the response, now they are circles with center and given radius, and pictorially we just represent this over here. Now I can just see the M circles, we just see the M circles of various magnitude just plotted on the Nyquist plot. Similarly, now we just go for the N circles. So the N circles, again it is the phase angle, it represents the phase angle. Now we just consider the same point, that is g of j omega is equal to x plus jy on the polar plot. Now the closed loop response again for this, here we just taken the previous m circles, we took the magnitude. Now in this case we just consider the face angle. The face angle of any rectangular form, it is given by tan inverse of b by a. So therefore your alpha is equal to tan inverse of, now the numerator it is tan inverse of y by x, that is b by a, and the denominator it is tan inverse of y divided by this a, it is 1 plus x. Now taking tan on both sides, that is we consider tan alpha is equal to n. So which means we just take tan on both sides. So tan alpha is equal to n is equal to tan of this entire expression. So here we already know the trigonometric expression, tan a minus tan b is given by tan, this is entire thing is a, this entire thing is a, this is tan a, and this it is, this entire thing is b. So tan a minus b, it is normally given by tan a minus tan b divided by 1 plus tan a tan b. Now from which we obtain, that is tan inverse of a, so which is nothing but y by x. So the tan and tan inverse just gets cancelled. So y by x, similarly all the other terms. Finally we just cross multiply it and we get the expression, and grouping the like terms together, now we get this expression. Now the addition of 1 by 4 plus 1 divided by 2n the whole squared on both sides of the equation, it yields this equation again, which is a equation which represents the circle. So again x squared plus y squared is equal to r squared. So it is a equation of circle. Now it is with center x naught is equal to minus 1 by 2 and y naught is equal to 1 divided by 2n. This is the center, and with radius it is 1 divided by 2n into n squared plus 1 the whole power 1 by 2. So this represents the n circle, that is the face angle. Okay, it represents the n circles with center and radius, and now you can see this, it is the representation of constant n circles. Again it is a circle and you can see it is for different face angles. So therefore this constant m and n circles, they are contours now which are used to identify the closed loop response from the open loop response. Actually we do not directly find the closed loop response, instead we calculate the open loop response from which we directly calculate the closed loop response. So thank you very much.